Alright, and here we are in our fourth section of 1-0, combining like terms plus solving. Now, I want you to write this word off somewhere on your notes. I want you to write the word simplify. And simplifying really contains two parts. There's combining like terms, and then there is also CLT for combining like terms, and there's also distribution. And we're going to talk about distribution in the last and final section. But what does combining like terms entail? Well, A, you have to have the same variable or the same letter. Okay. And part B is you have to have the same exponent. Now, this idea of the same exponent actually won't be applicable in geometry for some time. So we're not going to worry about that just right now. I really want to focus on the same variable. So when I look at number 1, I see 3x plus 12 plus 2x equals 37, and we want to simplify this by combining our like terms. So when you look on the left side here, 3x plus 12 plus 2x, what's your intuition? Which two terms do you believe belong together? And if you said the 3x and the 2x, you would be totally correct. They both have an x. The 12 is different because it's a constant, it doesn't have a variable. And so 3x plus 2x would of course give us 5x. You simply add the coefficients. So we have 5x plus 12 equals 37. Now, in this example, I can now write my Pemdas. And remember, we're doing our order of operations in reverse. And when you look at 5x plus 12, what two operations do you see? Well, we have the 5x, which is the multiplication, and we have the plus 12, which is the addition. We know that going from the bottom to the top, the first thing we have to get rid of is the addition. So what is the opposite or the inverse of plus 12? Well, it's going to be minus 12. I draw my brick wall, and what I do to the left, of course, I do to the right. So now I have 5x is equal to 37 minus 12, which would appear to be 25. And how do I get the x by itself? How do I get rid of this multiplication? Well, we know the opposite of multiplication would be division. And so, of course, we divide both sides by 5, and we get x equals 25 divided by 5, which is 5. I would encourage you to pause the video. I'm going to clear this off and move on to our next example. Okay, here we are in our second example. And let me give you all the equation. 9x plus 3 minus 6x plus 12. And let's go ahead and make this equal to 30. Alright, so as I look at this left side, I see that there is a lot. And I want to combine my like terms to simplify. So the first question we'll ask, what is my like term with the 9x? Well, does the 3 have an x? No. Does the negative 6x have an x? Of course it does. And so I'll use a triangle here to denote that. And I know that when I combine the coefficients, 9 minus 6 will actually give you 3x. Always pay attention to the symbol. Now here we have plus 3 and plus 12, and they're both constants. They don't have a letter with them or a variable. And what is 3 plus 12? Well, that would be 15 is equal to 30. Now at this point, I can draw my PEMDAS because I'm trying to get the x by itself. And remember, we're doing this in the opposite order. And so we see our multiplication, we see our addition, and we know we have to get rid of the addition first. What is the opposite or the inverse of plus 15? And of course we know that that will be minus 15. I draw my brick wall, and what I do to the left, I have to do to the right. Now, once those go away, I have 3x equals 30 minus 15, which we know is 15. And how do I get rid of the multiplication? How do I get rid of that 3? Well, we know the inverse of multiplication is to divide, and after I divide both sides by 3, I get x equals 15 divided by 3, which is 5. I hope that these two examples have helped, and I'll see you guys in our 5th and final section coming up.